Okay, guys, today we're going to do some applications of quadratic equations or quadratic functions. Or, in other words, we're going to work on some word problems where you have to use quadratic equations. Before we do that, though, we need to talk about what a consecutive integer is, because if you don't know that, you're going to be in trouble for this. So consecutive means one right after the other. So consecutive integers, an example would be 2, 3, 4, or 11, 12, 13. Those are consecutive. They come one right after the other. Consecutive even integers would be like 2, 4, 6, 8. You remember even numbers that come one right after the other, or 12, 14, 16, 18, and so on. And then consecutive odd would be 1, 3, 5, 7, 9, or if you started at 101, 101, 103, 105, blah, blah, blah. So when we're talking about consecutive integer or even integer or odd integer problems, we can represent them certain ways with variables. So like a consecutive integers, the first one we can call x. Well, the first one is x. Then the next one is x plus 1. And then the one after that would be x plus 2. And the one after that would be x plus 3, and so on. If I think about consecutive even integers, let's let x be the first one. So let's say the first even integer is 2. What's the next even integer? 4, right? So what would I have to add to 2 to make it be 4? I'd have to add 2 to it, right? And then the next one would be x plus 4, and then x plus 6, and so on. And that actually works with the odd integers as well. So if the first odd integer is x, let's pretend like our odd integers are 1, 3, and 5. So x is 1. Then what expression could I use to represent 3? X plus 2. And what expression could I use to represent the 5? So that would be x plus 4. It's the same. These two bullet points right here and here, they're represented the same way. Now that we've talked about that, now let's look at this first problem. It says to find two consecutive odd integers whose product is 99. So consecutive odd integers. So x would be the first one. Then the next one is the consecutive odd. So not x plus 1. The next one would be x plus 2. It's going to be the second number. So I've written that down just to make a note. Okay. So their product is going to be 99. Product is the answer to a multiplication. So I'm going to write x times x plus 2, so I've multiplied them, equals 99. Now you have to find those two integers, okay? So we've got to solve this. Well, if I distribute that x, I end up with x squared plus 2x equals 99. Okay, how can I solve this? Well, if I had an equation, because it's a quadratic, if I had an equation equal to 0, then I could factor, right, and work that out. You cannot factor this. All you know is two numbers multiplied together equal 99. You can't say, well, x is 99 or x plus 2 is 99. No, sir, that does not work. So I'm going to get this equation set equal to 0. So I'm going to subtract 99 on both sides. So x squared plus 2x minus 99 equals 0. Now I'm somewhere. If I can factor this, right? If I can factor that out, then I can set each factor equal to 0. Because if you've got two quantities that are being multiplied together and the product is 0, then one of them is 0, or either you're doing 0 times 0. Okay, so let's try that. So if I factor this out, I need to know the factors of 99, right? So that's 1 times 99, 3 times 33, 4, 5, 6, 7, 8, 9 times 11, right? I think that's it. So I'm looking for the pair. Well, let's back up. Let's make our box. So I'm going to have the x squared here, the minus 99 here. All right, and I'm looking for the pair that makes 2. Well, that 11 and 9 can make 2. And I want a positive 2. So if I do negative 9 plus 11, I'd have positive 2. So negative 9x, positive 11x right there. Now I can factor. So the GCF here would be x. The GCF here is negative 9. The GCF this way is x. And the GCF this way would be 11. So when I factor this out, I end up with x minus 9 times x plus 11 equals 0. So either x minus 9 is 0 or x plus 11 is 0. Here, x is going to be positive 9. Here, x is going to be negative 11. So which one is it? Okay, well, it doesn't make sense in this instance. When we say consecutive odd integers, we're not talking about negatives. Okay, so it's not really going to make sense here for negative 11 to be the integer that we're referring to. So we're going to go with the 9, right? So if x is 9, then x plus 2 is going to be 9 plus 2, which is 11. So my integers are 9 and 11. Those are my consecutive odd integers whose product is 99. And you might could have figured that out in your head, but you're not always going to be able to do that, so you need the steps process for doing that. All right, let's look at problem 2. It says a certain number added to its square is 30. Find the number. So this doesn't have anything to do with those consecutive integer problems. A certain number added to its square. So a certain number, so we'll call it x, added to, so plus, its square. So if I do the square of x, that would be x squared, is 30, so equals 30. So I have x plus x squared equals 30. Find the number, in this case, find x. Well, I can rearrange this, right, to x squared plus x, and subtract 30 on both sides, minus 30 equals 0. So whenever I'm talking about or dealing with quadratics, and a quadratic equation, it's probably easiest most of the time to go ahead and set the equation equal to 0. That's one of the first things I'm going to try to do every time, because then I can factor it or try to factor it. So let's list out, we need the factors of 30. So 1 times 30, 2 times 15, 3 times 10, and 5 times 6. And it's always best to go in order. I'm going to make my 2 by 2 box. So that's going to be the x squared. That's going to be negative 30. And I need a pair of factors to give me 1x. So that's got to be this, right? So I need 6, or negative 5 plus 6, right? So negative 5x plus 6x. Now I can factor it. So the GCF of x squared and 6x is x. The GCF of negative 5x and negative 30 is negative 5. The GCF of x and negative 5x is x. And the GCF of 6x and negative 30 will be 6. So I get x minus 5 times x plus 6 is equal to 0. So either x minus 5 is 0 or x plus 6 is 0. So x is either 5 or negative 6. So a certain number added to its square is 30. Find the number. So now this time let's double check, because both of those going to work. Is 5 plus 5 squared equal to 30? Is negative 6 plus negative 6 squared equal to 30? So we're going to test it out, right, and see which one actually works here, because it could be either one. We can't just eliminate the negative in this case. So I'm going to test it. 5 plus 5 squared, does that equal to 30? And then I'm going to test negative 6 plus negative 6 squared. Does that equal to 30? So I've got two cases to test. So 5 plus 25 does equal 30. So 5 works. Negative 6 plus, well, negative 6 squared is going to be positive 36. Also is equal to 30. So that one also works, doesn't it? So they actually do both work. So the number, a certain number added to its square is 30. So it could be 5 or negative 6. Either one. So there are two possibilities here, right? And that may not happen every time. Sometimes you might be able to eliminate like we did in the first problem. And sometimes you might have two answers. It depends on the situation. Because sometimes a negative, for example, doesn't make sense in the context of the problem. Let's try one more problem. The square of a number exceeds the number by 72. Find the number. The square of a number. So let's call that x squared. Exceeds the number by 72. That means it's more than the original number. Is 72 more than the original number? So this is equal to the original number of x plus 72. Okay, so if I want to find my original number, first thing I'm going to do is I'm going to change this or write this in standard form. So I'm going to subtract the x because I don't want to subtract the x squared because I don't like to have a negative x squared if I can help it. And I'm going to subtract the 72. So I end up with x squared minus x minus 72 equals 0. Now I'm going to get ready to factor it. So there's my x squared. There's my negative 72. Okay, and I need to find the factors of 72. 1 times 72, 2 times 36, 3 goes into 72, let's see, 3 goes into 7, 2 times 24, 4 goes into 72, 13 times, is that right? 4 goes into 7 once, no, that's not right. 4 goes into 7 once, with 3 left over. 4 goes into 32 8 times. 5, 6 goes into 72 12 times. 7 is not a factor. 8 times 9. Okay, so now we want the pair of factors whose sum would be negative 1. So that 8 and 9 would work here. I want negative 1, so it'd be 8 plus negative 9, or 8x. And then negative 9x. All right, now let's factor. Here, my GCF is x. This way, the GCF would be 8. If I go this way, my GCF is x. And if I go this way, my GCF would be negative 9. So I end up with x plus 8 times x minus 9 equals 0. So either x plus 8 is 0 or x minus 9 is 0. So x is either negative 8 or positive 9. So the square of a number exceeds the number. It doesn't, both of these actually should work. There's no way to eliminate either one, but we can test it out. So I'm going to double check. Negative 8 squared, is that equal to negative 8 plus 72? So that would be 64. Let's see, is 64 equivalent to negative 8 plus 72? It sure is. So negative 8 works. Let's try 9. 9 squared, is that equal to 9 plus 72? Well, 81 is equal to 9 plus 72. So the answers here are, the number in question is either negative 8 or positive 9. Okay, guys. Now you're going to try the rest on your own. So I want you to pause the video and do 4 through 8. So pause the video and try those now. Hey guys, welcome back. So now you're going to need to check over your answers to each of these problems. So here's number 4. So go ahead and pause the video and make the necessary corrections. Okay, let's look at number 5. Okay, check number 6. And here's number 7. And number 8. Now, if you have questions about any of these problems, if you're unsure, then bring them to my attention so that I can help you. I'm happy to help. Just let me know. Once you've turned this in, go ahead and complete your independent practice for this lesson. Good luck.